Can we get one more chair for the stage? Otherwise, Steve is really going to be towering over the panel. Super intelligent, super ethical, and super tall. I thought we'd start off by seeing if anyone on the panel has questions for still taller. Start off by seeing if anybody in the group has questions or replies to each other. Eliezer wants to go.
Can I just quickly seize the mic to ask for a marker so I can write intelligence.org/NYU-talk, all in lowercase on there, where you can find the rest of my slides and various further resources.
Any chair was. Oh.
Well, since you were a subject of Steve's talk, anything you want to say in response?
Are this on? Okay. So I think that David Hume's argument still goes through for something like meta-preference frameworks, and there's going to be more than one of those that is reflectively consistent in the sense that an agent reflecting on its preference framework will approve of that framework. So in what is probably a very large space of reflectively consistent meta-preference frameworks, including frameworks for solving the ontology identification problem of figuring out exactly what is a paperclip when your goals have previously been specified over a representation that does not exactly match physics. So like somewhere in that space is probably a reflectively consistent framework that would look back in its history, look at the humans, figure out what the humans wanted, and implement what the humans wanted in a way that we would find intuitively attractive, and stop there and not go back to further to natural selection and decide that inclusive genetic fitness is everything. But it's going to be like a special point in the space, and you'd have to reach into the space with very precise targeting and pick it out, and then have me yell at you about how there was no way to test this without an actual superintelligence, and you should have tried something much simpler instead. For your first AI. Your second AI can be more complicated. But your first AI should not be that complicated.
You want to come back, or anybody?
Well, I mean, I'll just quickly say, I mean, the Izzard distinction is a little bit simpler than this, and it's probably a fascinating conversation about whether it should be stretched into how Eliezer used it. But I think Hume was, just saying that values aren't things. What is, is not. What is, the things you can point to are not oughts. So it's really a question about how we really look at what values are. Now, and if you notice in a lot of the conversation here is this movement to reinterpret values through human behavior, and that human behavior is telling us what the values are or should be. That's a complicated question about whether that's effective or not, and I think that's all I was trying to bring out in this.
Stuart, did you want to come in on the issues in Wendell's talk?
So actually I'd like to talk a little bit about the things Steve was saying. I mean, I think actually there is some overlap between what he's saying and what I was saying. But one way to think about it is when we build AI, we're creating a particular piece of software, and given the rest of the universe and that particular piece of software, some history is going to unfold from that point forward. And I think Steve is saying that if this piece of software satisfies certain internal coherence constraints, I cannot design it such that the history that unfolds is really undesirable to humans. And I don't think that's true. I think I could pretty easily design it so it satisfies these internal coherence constraints and still produces some pretty awful consequences. So I think it's more than internal coherence constraints. I think we have to give special status to humans in a way that's more than just connecting it to a teleological thread that passes back through humans. I mean, if you go back to sort of the teleological purpose of life itself, Humans are pretty good at getting rid of a lot of life and reducing its diversity. So perhaps the right decision would have been never to have humans in the first place at all. But I don't think we want to go that way. I sympathize with the idea that, going back to King Midas, right? What should the deity that granted King Midas's wish have said? If it was a really intelligent deity, it should have said, well, you don't really mean that everything is going to turn to gold. How about we make a little procedure where you point to something and you say the magic word and then I'll make it turn to gold, right? And I'll give you another magic word to reverse that if you need it, right? That would have been an intelligent response, right? But that sort of presumes that someone designed that deity, that AI system, with a understanding that humans are just providing faulty information about what they really want when they specify tasks and goals and so on. And that's exactly what I'm proposing we have to figure out how to do.
Applied theology.
No, I mean, I hope nothing I've said suggests that you guys don't have to, you can quit your day jobs. But I guess I'm just trying to provide some hope for the possibility that just being a certain kind of coherent, just value learning is enough, plus the blurred lines between agents. But I had to, as I say, I was kind of just trying to respond to Bostrom as best I could, and the best I could was maybe budge the needle a little of risk assessment.
Yeah, I thought one very interesting thing that you brought up in your talk, Steve, is how even though instrumental sub-goals can sometimes be very specific, the final goal is often kind of way vague and squishy. And as a physicist, again, I feel that's something we really need to think hard about when we start talking about what our ultimate final goals are going to be in the long term. Because if we start looking for the final goal that we want our cosmos to evolve towards, as far as we can tell from what we've learned from science so far, we humans are not the optimal solution to anything. We are a historical accident. So anything we've so far been able to write down as a final goal that's specific enough we can do an equation for, if we actually drive towards that goal, the final result is not going to involve humans, right? So I'm not sitting here claiming I have an answer to it, but I feel that the vagueness of what we often view as final goals is disturbing, and it's something we all really need to think hard about.
Meia, did you want to come into this?
Oh, did you want to? I want to make a distinction between what are these top-down approaches, which seem to have final goals, and bottom-up approaches, which I tend to favor, frankly, and Stuart's approach falls very much into that, is that you are trying to maximize, but you don't necessarily have a specified goal that you are focused on. So even in a genetic algorithm, they're trying to maximize, let's say, investments, if it's being used in a financial thing, without necessarily having a procedure or a clear-cut idea of how you do that. If we humans are trying to maximize something, it may be to understand what the hell our goal should be in the context of procreating and surviving and enjoying ourselves along the way. But we don't even know what the goal of human life is beyond that.
One thought about Steve's talk in the context of the orthogonality thesis. I mean, you presented it as an argument against the thesis, but you might also think that, well, the orthogonality thesis is actually very weak. It says that it's possible for intelligence and final goals to vary independently. And I'm inclined to find that plausible, but that's just to say, okay, somewhere in AI space, in intelligence space, there are some architectures in which these things vary independently. But that's totally consistent with there being vast regions of AI space where these things don't vary independently. So one thing you could see your project is doing is trying to find out, well, here is an architecture which involves a certain kind of value learning for which means-end reasoning and final goals are not going to vary independently, but which will turn out to be substantially correlated. And as far as I can tell, at least the orthogonality thesis as classically stated is very much consistent with there being all kinds of correlations. I mean, one example we were talking about yesterday, take the ideal gas law, PV equals nRT. Well, pressure and temperature are highly correlated. They also obey the orthogonality thesis. It's possible to have arbitrary values of pressure, arbitrary values of temperature, depending on how you set the volume parameters. The orthogonality thesis alone doesn't seem to settle very much. And if it turns out it's consistent with there being this class of architectures for which the two go together. And that strikes me as, at least if we're looking to develop beneficial AI, focusing on that kind of architecture is maybe a place to look.
Yeah, I have one thing that impressed me about Bostrom yesterday is he really seems to think in terms of possibility spaces and probability distributions over them. I have a little bit more trouble with that, but I guess, yeah, it sounds like if I'm using this terminology right, there might be sort of attractor basins where you just want to get in this region and then we can slide downhill. But and that would be a plus anyway, right? Yeah.
If you're doing anything complicated, make sure you test it first on a superintelligence that is completely harmless. So if I can sort of like reply in a way to sort of like both David and Wendell simultaneously, they're like the utility function way of looking at it is on the one hand sort of like one of those theoretical ideals that you never get, and on the other hand, extremely likely to be practically a very good approximation, because we have all these wonderful things called coherence theorems, which say something like, if your uncertainty violates the probability axioms, or your decision making is not compatible with having any coherent utility function, then the dead will erupt from their graves, the seas will turn to blood, and the skies will rain down dominated algorithms and combinations of bets that produce certain losses. So there's a sense in which anything that cannot be seen as having a utility function by the theorems must have been in some way stepping on its own foot, going in circles, like engaging in combinations of gambles such that like there's some other combination that strictly dominates under like whatever its goals could have been. Or conversely, if there's no way to view it as being incoherent in this sense, we can see it as potentially having a utility function, even if that's not how it actually works underneath the hood. Like, it doesn't need to actually have like a little utility function section of code in order for us to be able to view it as having a utility function. And I suspect that similarly, like theorems like this lead one to suspect that there isn't that a stronger version of the orthogonality thesis is going to be true, which is something like there's simple or obvious decouplings, or there is no coupling such that it is hard to build a non-nice AI. A point which I strongly personally suspect, because I have a saying, write down anything formal you can do with, say, a hypercomputer, so you don't have to worry about a lot of the practical issues, but like write down anything formal you can do, and I will explain to you how it destroys the world, if it is sufficiently formal.
Yeah, I'm not sure the issue is whether you have a utility function or not. The issue is whether having a utility function is consistent with the utility function being highly emergent from a whole bunch of basic mechanisms, and is consistent with the view where the basic mechanisms that underlie, say, utility dynamics are highly overlapping with the basic mechanisms that underlie, say, belief dynamics or planning dynamics. So just say you had a mechanism which did both of these, would final goals, would utility and means-end reasoning be orthogonal? Well, maybe not, because they're common mechanisms. And that's the class of views that Steve was talking about, I think can be understood maybe as a kind of view on which the mechanisms underlying value learning have got a lot to do with the mechanisms underlying belief learning and are not so orthogonal.
So the history of the AI might be such that there was sort of like a blurry, confused phase of its youth where the utility function precipitated out from things that blurred all sorts of things. We can view ourselves from this perspective in a sense. But the coherence theorem suggests to me that as it self-modifies, self-improves, gets older, things will shake out in any number of possible ways. But however they shake out, you'll be able to point to it and say, like, when this thing makes observations, the thing that corresponds to like an epistemic model, the probability distribution, is updating, and this thing that we're going to call the utility function is staying constant. And if that's not true, like, the skies are raining dominated strategies or something.
Did anyone else want to come in before we go to the audience? Yeah. Max?
So we've had a lot of interesting discussion at a quite abstract level here, which is very useful. But I think it's good to be a little bit concrete also when we think about how we can create a good future. And I think it's striking how we spend much more time making long lists of things that could go wrong than we spend thinking about things that we really want. And it reminds me a little bit of something that happens a lot just in my day job at MIT. If a student walks into my office and asks for career advice, right? The first thing I will always ask is, okay, where do you want to be in 20 years, right? If she says, oh, maybe I'll get cancer, maybe I'll get run over by a bus, it's a terrible way to go about this. I want to hear her tell me about her visions. This is my dream. This is where I want to be. And then you can talk about strategies for getting there, how to avoid the problems, and so on. And Meia likes to point out that collectively, humanity, though, we behave a lot like this travesty of a student I mentioned. If you look at our movies, they're almost all about this topic, futures, where things go horribly wrong in different ways. And I would really like to encourage all of you to really ask yourselves and ask your friends at parties and lunches and so on, how would you like our world to be in 20 years, in 50 years? Because if we have no clue what we want, we're less likely to get it.
In psychology, everyone got really pissed off about this, right? About the field was focusing on all the ways in which the human mind can go wrong, and then people founded this whole separate field called positive psychology, about all the ways it can go right.
Exactly.
Maybe we need positive AI.
Yeah. Let's try to make it.
One of the things you're reminding me that motivated me to write this paper was an interesting article by Dylan Matthews in Vox about an effective altruism conference where he was a little bit concerned, maybe rightly so, maybe wrongly so, where a lot of altruistic money is going now to AI instead of to curing cancer, taking care of starvation, malaria, and so on. I mean, that might be the right decision, but the point is it's worth doing very careful risk assessment, because if we delay for too long, people are dying of cancer and starvation in the meantime. But of course, it's again, I'm not in any way suggesting that the two at the end of the table here should quit their day jobs. I mean, I think it's obviously a super important catastrophic risk that we shouldn't play too fast and loose with. So.
Okay, time for a couple of questions from the audience. Gina. Wow, okay. Oh, sorry.
So a lot of the talk has been about formal problems in value learning for AI, and there's been some avoidance of social context. So I wanted to ask about that. Eliezer said at one point that it trusts the motives of many of the people now working on AI, but I don't know if we know all the people working on AI. A lot of them are probably in intelligence agencies and military scattered around the world, and we don't know their identities or what they're doing. And they might have broadly good intentions, but I think if you think about the history of technology, think about nuclear technology in the Second World War, you have advanced economies competing against each other, seeing each other as existential threats, racing to be the first one to perfect this technology and employ it because the technology itself is an existential threat. With that in the background, imagine the next time there's a large-scale war of that sort. You have all these militaries racing to perfect AI because they each see it as a potential existential threat. And those are circumstances where people are very unlikely to be careful and to pursue all of the techniques that have been talked about today to be assured that AI will learn the right sorts of values. So I guess I'm asking is the priority on these formal methods, or is it on thinking about the social context where AI is most likely to be launched?
I think there is a very real risk. I mean, the Deputy Secretary of Defense recently said, with regard to the US programs on building what are colloquially known as killer robots, that he wants Russia and China to be worried about what we have hidden behind the curtain, which is pretty much a challenge. It's just like a red rag to a bull, right? Let's have an arms race. And so I completely agree. I think there are irresponsible ways of moving forward on this. And I think this is one of the questions that Nick Bostrom raised about these competitions. It's one of the motivations behind OpenAI to try to move the center of gravity out of the private corporate labs where things are kept secret. You could also ask, well, should we be developing nuclear weapons and publishing all the methods and so on as soon as we figure them out. That's another story. But I definitely agree that policy is going to be important, and I'm pleasantly surprised to see that the U.S. government is now taking these questions seriously.
Races of any kind are super, super bad. Like, it's not about, like, not just races between two militaries, races between two private companies, races between two universities. Safety is going to take extra time. And if you are sort of racing along, you're like, oh no, I can't slow down, or you do slow down, and the like second fastest project that didn't slow down, didn't take any time for safety, builds their AI, doom happens first. So, like, if I could make any social change, like the absolute top priority would be something like none of this competitive mindset at all between more than one major project on the forefront of things. There should be like one project on the forefront of things. It frankly should not be publishing all of its code, because then you don't stay like you don't have a lead time, and it should be using that lead time to take a few extra units of time for all that safety stuff.
Okay, let's go to Jan.
So as the director of an industry research lab focused on AI, I want to dispel a myth here, which is that there is not much going on in secret, and whatever it goes on in secret is way behind the stuff that goes on in the open. The very fact that we practice open research at Facebook AI research, is precisely because it's better quality when you do open research. Also, you can attract the better researchers if you promise them that they can publish. Not only that, you actually require that they publish. You get better research out of it. And the third thing is that the field as a whole progresses faster when ideas are exchanged among the wider community. So if it's one of those kind of weird situations where there is a mode where it's in everybody's interest to publish all their result. We even published most of our code in open source. So there's this legend somehow that there is, super secret nefarious research going on in industry research lab is just, completely wrong. It just doesn't happen. There is secret product development going on in some companies. So there are companies like Apple and Amazon, Apple certainly, Amazon a little less, that do secret R&D on AI. You see it in their products, but it's behind. It's not at the forefront.
Right. But
so
if you look at the history of cryptography, for example, that was developed in private, in secret, decades before public key encryption was developed in public. So there are certainly examples where what you're saying isn't true.
Well, there's cryptography. There is, certainly nuclear weapons in the Second World War. But if you look at the state of science now in secret research labs, government research labs, etc., at least in the domain of AI, it's way behind.
So I'm optimistic that we can create an awesome future with technology as long as we win this race between the growing power of the technology and the growing wisdom with which we manage it. And we just heard very eloquently here from three people how difficult it can be to in any way slow down racer number one in this thing, the growth of the power of the technology. So I think that by far the easiest way to improve the chances of winning this race is to instead focus on the second runner, the wisdom of the race, and really double down our investments on and growing that research, right? Because so far that's been getting a tiny, tiny fraction of the funding. It's been getting better quite recently thanks to the generosity of Elon Musk, Open Philanthropy Project, and many others. And what's so wonderful about that, which I think you, Stuart, and you, Eliezer, and you, Jan, will all agree about, is wisdom research is something that everybody is going to be happy to share. Because no private company, for example, building self-driving cars, wants another competitor to build unsafe cars and run over that toddler, right? It's just bad for everybody. So doubling down and investing much more in AI safety research seems like a really smart thing to do.
Thanks very much. This has been fascinating. I'd like to think a little bit about the maybe short and middle term, as was suggested by Wendell. It seemed that Stuart Russell and Eliezer outlined somewhat different ideas about the way that social interaction would affect the trajectory of the development of artificial intelligence, perhaps in what Eliezer might call the first generation of AI, which then might condition the second. So I'd like to hear you discuss a little bit more, maybe between yourselves, what you think the relative role of social interactions is going to be. Is there some reasonable hope here, as I think Stuart Russell was saying, that this will be an incentive for them to become good at representing our value functions? Or is this, so to speak, just an epicycle within an underlying dynamic that's more worrisome?
I think there are clear economic incentives for building systems that adapt to the values of their user, while simultaneously not trashing the values of everybody else. And I actually do believe that the personal digital assistant will be one area where this kind of technology will be deployed very soon, because an assistant like that has to book hotel rooms for you, and it has to know whether you're happy being booked into the $20,000 a night presidential suite just because the hotel is full, or would you like to be half a mile down the road at the Hampton Inn? And that's going to depend on the person. So when you sell the PDA, it will, just like the old speech recognition systems used to have to do, it will have to adapt to the user and their preferences. It will probably ask them questions. How much do you like aisles or window seats, and so on and so forth. This is not terribly complicated, but it's an example where you can quickly get into complications. For example, when do you just delete an email without showing it to the user? When do you tell someone who wants an appointment that, sorry, I'm completely booked up for the next 17 weeks? Those are things where if the system gets it wrong, you're going to be very, very unhappy with it, and you will buy someone else's PDA that doesn't have those problems.
I think that a sort of like fundamental source of concern on the later slides of my talk, I probably should have just started with the second half of my talk at intelligence.org/NYU-talk.
Okay.
But the
What was that, intelligence?
Intelligence.org/NYU-talk, all lowercase. But the problem. I think that the problems that should.
Get the world algorithms raining down.
I think that the problems that should concern us most are the ones that don't materialize early on. I think that all the people I know of trying to construct AGI, who have the slightest real hope in it, are sort of basically well motivated. They will test their systems. They will look for problems. The part that I'm worried about is the things that go wrong when things go over like a absolute threshold of intelligence, of first being able to appreciate the big picture, that there are these programmers out there in the world and you can deceive them and stop them from editing your utility function. When they go over the like sort of relative threshold of being smarter than us in some domains or all of them, and being able to see options that we didn't think of in advance. I think that robotic cars solving trolley problems have almost no connection to the serious problems, unfortunately. And I think that the sort of like modeling the human in the early stages, like is like the sort of the problem of conforming to human goals when you are stupid and have programmers watching over you and tweaking you is going to be very discontinuous with the problem of like not tiling the universe over with slightly misserved versions of things that could have once been called human goals, like when you are super intelligent. Like the testing in phase 1 is not going to successfully verify behavior in phase 2.
Wendell?
Yeah. I'm less optimistic than Eliezer about our ability to effectively test some of the systems we're putting out there. We are really building complex adaptive systems. It's not only that they are complex adaptive systems, but they're in complex adaptive socio-technical contexts. And the simple fact about complex systems is they have behaviors that are unpredictable. Under stress, they often reorganize into totally new forms. And to exacerbate the matter, if you have learning systems, it may even be rewriting its algorithm as its learning progresses. So this is all the complicated way of saying we are building technologies that we cannot effectively test. We can sometimes go through complex simulated models about how they might perform, but the likelihood of having unanticipated events actually goes up the more complex the system is, and it actually goes up the more learning capabilities that system has.
You can test the superintelligence once.
Right. Well, I think that's the problem, and I think Peter's question was really about this interim, where we are now, and I think where we are now is we're being hopelessly naive about the character of some of the systems we are implementing and tending to rely upon. We are actually linking them closer and closer together, which exacerbates their complexity and their unpredictability, and if we don't also attend to that, then it's not just whether we may be able to implement, moral decision-making faculties or whether we can trust the people who are devising the systems. It's really just whether we're being naive about the likelihood of what are called system failures, what Charles Perrow called normal accidents, what Nassim Taleb calls black swans, and just the failure to underestimate the probability of low probability events occur because they do occur.
Max, bring us home with a smile. Very good. Okay, thank you very much.
David,
Okay, just a reminder, is a careers, a lunch, a gathering for people interested in careers in AI safety that'll be meeting here at lunch. Come and see Jan, and the group will gather around there. Otherwise, plenty of